did it by hand.
That's totally fine.
But I used 2. It makes a difference.
It does make a difference, and don't worry about it. Kate asked a very good question. Well, she went ahead and did the quiz already, and one of the questions on the quiz is how large a sample do you need to be 95% confident? Blah 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 blah. Well, 95%. We've been using 2 instead of 1.96 this whole time, right? If you use 2, what happens to your sample size?
So many people put it.
It's larger because you're actually a little more confident. That's okay.
So, okay.
Emily knows that. She knows about the docking points for that. Okay? She knows somebody using 2, somebody using 1. If you use the program, it's set to 1.9. It's actually 1.95543. It's some ridiculous 100 decimal long number that ends up being the same as 2, arguably. But don't worry about that, Kate. Please don't worry about it. Great question. Okay, let me come back to here. Oh goodness, let's not lose that. Okay, let's not break that either. So what I want to do is, I want to kind of read, oops. Sorry. Yeah. I want to just take a quick look back at, these are they're getting slightly old now, but don't worry about that. Worry about reading it. I want to make sure that so much of what you guys are going to have to deal with in the world, now you're in focus, there we go. So much of what you guys are going to have to deal with in the world is interpretation of these things versus construction of these things. So what you just learned how to do in class, awesome, is to construct confidence intervals on proportions. Yay, that's great, I love that. And that's an important skill to have. Natural resources, HDFS, this is the kind of stuff you know all the time. What percentage of the floor is covered by ferns or forbs or other names I don't remember. But there's all kinds of terms. But very often, you're going to have to deal with this, where you have to absorb what's already been reported. So take a look at that. Tell me what you think about it. I should really update this. More a little current. What do you think? You believe the title?
Not really.
Say no, I heard not really over there. Be more specific.
Well, it's plus or minus 4, so it could be.
Check it out. There is Obama's approval rating, according to Gallup. Now they're saying, let me pull this out of the way so you guys. They're saying that Obama's approval rating reaches 50% for the first time since spring. I don't know what it was before. I'm guessing it was below 0.5 in P hat. No, that.
It said it was 40s.
Mid-40s for much of the latter half. I don't know what it was the last time they measured it though. Correct, so mid-40s, 45, 46%, something like that. Good. But now they're saying, reach the symbolic 50% mark. Do I believe that? Well, I don't know. Did it reach 50%?
Yeah.
It could have. But we sure as heck can't say it did. Because where could it also be? It could be a 4, well good, that would mean it would actually exceeded it. But it could just slightly been a 46, or 47, or 48. Now some of you are going, I don't really care about this. That's okay. You don't have to care about this context. The mathematics you should care about. This headline is not supported by this study. The P hat value landed at 50%, yes? P hat came in at 50%. That does not mean that, what's it?
The actual
approval rating of all Americans that are out there. They only surveyed how many?
You answer the phone.
Hang on. 1,544 adults, which is pretty large. I'm surprised that percentage is 4%. It should be much less than that, but whatever. Even if it was a 2%, remember 1,067 is the cutoff for 3%. Seems like that should be much lower. But even if it was a 2%, I still wouldn't believe it. Because here's why. Think of the approval rating as a fish. And think of that green that green block as a tank. There is his approval rating, and you don't know where it is. It might be there, it might be there. It might actually land at 0.5. But the fish is swimming in that tank. The fish is swimming in that tank. This is your parameter that you're studying. This is your parameter. And he's floating between the sides of this tank. The best you can do is draw a tank and let the fish swim in it and say, I don't know if it's 50%. I can say with 95% confidence it's at least
The fish under the tank.
46%, or at most 54. Now, if it was 40%, say a week ago, can we now say it's significantly higher than 40%? Assuming no margin of error on the 40. Let's assume none, because I'm not going to give it to you anyway. Yes, because 40% is down here. And even if 40% had a 4% margin of error on it, it would still be significantly higher, wouldn't it? Because if 40% could go as high as 44, yeah, I'm just making up a number. Absolutely, absolutely. I'm just making up numbers here. If it was at 40 plus 4, it'd be 44. You've got a minimum of 2 percentage points of difference between them, yeah? Minimum of 2. But because they're using the number of 50%, and that's in the tank, there's no way of knowing where the fish, i.e. the parameter value of approval rating is compared to the tank. Go, Kate, please.
Just using the program we just did to look at their sample size and whatnot.
Yeah.
With 95% confidence with 4% margin of error, they only need 600.
I know. That's why that.
Wouldn't that mean that their margin of error is actually much smaller, or they're much more confident?
Yes, one or both. That's what kind of confounds me about why they reported this. Remember, when you run the program, you are accepting a margin of error and accepting a confidence level. You don't necessarily get either of those things. So maybe what they did was they based the sample based on some other margin of error, and then got. I can't explain it.
Maybe they didn't make any phone calls, so they just put some.
Maybe they didn't make any phone calls, some numbers up.
Maybe-
Possible, Michael. Hopefully not. Scallop. Michael, go.
Would it be statistically correct to do half of 95% and just do what's above 50% on that? So they're with 47.5% confidence that it's over 50%?
Damn, that's a damn good question. You're selectively, the problem with that is it's no longer random. If you're only taking the top half, so I see what you're saying, and it's correct in one way and incorrect in another way. It's correct in the way that, okay, here's a bell curve, there's 100%. 2 standard deviations is 95%. Boom, 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 boom. There's half of 95, was it 47.5%? Okay, I like that, but you also have to pair that with there's a 47.5% confidence that it's below 50%. So yeah, mathematically it works, but you're also, it's kind of like, see, here's what you see, but there's this back here. Well, first of all, you're below 50% confidence, which is like, you might as well flip a coin to decide at that point. But, so mathematically you're not wrong, it's just that you're being a little bit misleading in that you're only showing the positive side of the result. There is a negative side to this result, you're just choosing to only show the side of the tank. So mathematically, yeah. Statistically, I wouldn't do it, because people are not going to be pissed at you for, first of all, 45% confidence.
Well, most people don't read that part, so.
They don't! That doesn't mean you shouldn't be! My God! Now, and some people are going to say, well, who cares? It's a bonus approval rating. Right? This doesn't affect me in my life. You're right, it might not. But something else might that is expressed as a percentage. So as long as you can understand the math behind this, you got the math behind everything. Here's another one. And I am going to update these. I apologize for their slight datedness. 2009, about 5 years old. War on Terror update. Go ahead, read that one.
Actually, it's good to have some.
I apologize for the datedness.
It's good.
But again, it's not the datedness so much as it's the application of the math and the statistics behind it. So, what do you think? You think more people think it's going to get worse than get better?
Even at their highest and lowest, they're different.
Check it out. Here's the intervals for you. They told me that based on the survey, 34% of that sample believe it's going to get better. So here's 34%. And 39 expected to get worse. So clearly 39 is bigger than 34 by 5%. So you say, well, there it is done. Time out. That's assuming you ask every single person in the population, right? Every single voter. So what you have to do is slap the margin of error. Laura, you said the right thing over here. What you said was correct,
They
though.
don't have 100%.
Because some people had no opinion. you can take out the other, what is it, maybe 20%-ish, 25%, and just let them have an opinion. So then they're on there too, but it's just that I'm just comparing to get better and get worse for now.
Didn't you once say though that within a 1% difference between it, that it's basically there is no difference?
Depends on that guy. Yes, it depends. It always depends on the margin of error. And hold that question, give me 2 minutes on that. That's an awesome question, Kate. Give me 2 minutes. I want to answer that very, very important question. This one has a 2% margin of error. Notice the sample size is hidden from you? And that's okay, because they gave me a margin of error. If I needed to, could I reverse engineer their sample size from this? Of course you could, because they told you 95% confident, right? They told you the margin of error was 2%. You could run that through your program and figure out roughly what their sample size was. So I don't need to know that in this case. But I've got the 2%, so I can apply the 2% to the p hat here and the p hat here. Once I do that, do I believe with 95% confidence that a higher percentage or think it's going to get worse? I do now.
Yeah.
They're not touching, are they? There's at least a 1 percentage point difference between them. Even this at its highest is lower than this at its lowest. Bring the fish back. Bring the fish. Here they are. Here they are. This is the population parameter of those who believe the war or the situation is going to get worse. And this fish is the ones that thinks the war is going to get better. Now, we don't know what they are. We'll never know what they are because they're out in the population of all the voters that are out there, yeah? So, this one is going to vary between these two values. The lowest it could possibly be is if the fish nosedives into the tank on this side, which puts him at 37%. The highest this one could be is over here at 36%. Will this fish ever be able to get into this fish's tank? Not with 95% confidence, We can expand the confidence to make the tanks touch, but that's bad statistics. You pick your confidence level and you stick with it. You don't change it to fit your situation. So, that fish with 95% confidence will never get into this fish's tank. Which means we can make the claim that a higher percentage, by at least 1 percentage point, a higher percentage think it's going to get worse than get better. I believe that headline. That's a headline I can be like, you know, I'm good with that one. I don't believe the other one because the damn fish can swim all over that tank past 50%. This one's legit to me. This one's legit to me. You see the difference? Kate asked an awesome question. I want to repeat it. I mentioned something at 243. I'm proud you remembered it too. Essentially, you can make any difference significant. Here's the deal. Suppose this was 39, and suppose this one was actually 38 percentage points. So suppose this one was actually higher and set it up on 38. With a 2% margin of error.
Oh, so it's with the margin of error. Okay.
Gotta be with the margin of error. Would 39 and 38 be any different with 2% margin of error? No! That's a statistical dead heat. Would 39 and 38 be any different with a 1% margin of error? 1% margin of error. No, because 38 could be as high as 39, and 39 could be as low as 38. They're all over each other, yeah? Could 39 and 38 be significantly different with a 0.25% margin of error? Yes. With a 1/4% margin of error, they wouldn't touch anymore, would they? They'd be apart. Their margins would be this tiny, right? However, what would it require to be 95% confident at a 0.25? Go calculate it! Calculate it right now! What would it require? A 0.25% margin of error and 95% confidence. I'm sorry, JC. I apologize. I apologize. What's it going to require? A lot of people define a lot. Define a lot.
154,000.
154,000-ish people, huh? Did you put in 0.0025 for your margin of error? Right, because 0.25 is 25%, 0.025 is 2.5%, 0.0025 is 1/4%. It's going to require 154,000+ people to do that. Exponentially higher, and the problem is, when you think about that beautiful formula, think about where the margin of error is. It's in the denominator. It's a decimal. As you square it, it actually gets smaller. You see? All that taken together makes the sample size grow exponentially as a function of your decreased margin of error. So, yes, you can make 38 and 39% be statistically different. I have yet to see a study that has 154,000 people in it, though. That's the problem. Which is why 38 and 39% are usually not statistically significantly different from each other. Be wary, I leave you with this caution. be wary of studies like this. I have to get a new one, this is very old. Be wary. Be wary. Clearly, the Muslim men are worse off than the caste men. Or excuse me, yes, the elite caste. Clearly, 52% is bigger than 47%. So clearly they're worse off. More than half of the Muslim men are unemployed, whereas less than half of the caste men are unemployed. Clearly, it is clear to me that 52 is bigger than 47. Clear to me today. Clear to me as the day as the sun is in the sky. As the moon was full last night. Clear to me. And Christina goes, yes, we get what you're saying, right? You can't tell anything! You can't tell a damn thing. Look, here, I ran some numbers for you. I'll put this down. There's a sample size of 100. If the sample size were 100 in the study, can you tell the difference between the two castes? No, fishies are all over each other's tanks, yes? How about we dug the sample size to 1,000? Any difference? I said 500. There's 500. Notice the margins of error shrank down?
They're still on the same.
Is there a difference? They're still overlapping, aren't they? Here's 1,000. It looks like the same. It looks like they just got wider, but they didn't. The scale changed on the axis. They're actually narrower. Can we tell any difference? Not yet. They're still overlapping. How about now? Now you can. But who the hell knows how many they surveyed? Did they survey 2,000?
I doubt it.
Have we answered that question?
Those
Didn't
are
we?
the people that don't even want to talk to, so how would they?
And that becomes a bias question. That becomes a bias question, what your first project is all about. That becomes a how do you go get them? Thank you, go get them. That's enough for today though, yes? Yes! So, for next time, I'll see you for a week, I'm gonna miss you. Next time we'll deal with the Guinness Brewery. We'll deal with the time interval of 1 minute. We'll deal with touch therapy and all kinds of other things that you might not think has anything to do with statistics, but has everything to do not only with statistics, but also the next branch of where we're headed, statistically. Yes! Catch you then? Remember, you can turn the quiz that was due, the one quiz for today, you can turn in next time if you want to. The one about this stuff, by all means. Now that you have the tools for it. Cool? All right. Awesome.